Yes, like every time we'll just have a revision. Okay, it's always better to revise the things what you learned before so that the concept is very clear. Okay, so we will start. We were doing depression in freezing point, correct? And I had told you what is a freezing point is, correct? When you call as a freezing point in terms of vapor pressure when you're discussing, freezing is where when you have a liquid and you're trying to convert that into a solid. Okay, the temperature at which you convert this liquid into a solid, that's the freezing point, correct? Now, when you're talking in terms of vapor pressure, you know liquid has more vapor pressure. Okay, I have shown the diagram so that it becomes like easier for you. So here you can see there are more vapor pressure, and in the solid state there is less vapor pressure. Okay, reason for this is the force of attraction. Okay, because in the liquid, you know, particles are far away from each other. Okay, the kinetic energy is more, so the force of attraction between these particles are little less. Okay, when you are comparing with the solid, in the solid these molecules are tightly packed. When the molecules are tightly packed like this, the force of attraction between them is very strong. So the amount of vapors which will be produced will be less. Okay, and here the amount of vapors in the liquid produced will be more. Okay, force of attraction. Yes, very good. Okay, so this is the one point which you need to keep in mind about the liquid and the solid. Okay, now coming to converting this liquid into a solid. So now you can see here vapor pressure of liquid is very high compared to vapor pressure of the solid. So if you want the liquid to go into a solid state, this is what you have to do. That more vapor pressure should be reduced to a less vapor pressure. So how can you reduce the vapor pressure? A vapor pressure can be reduced if you reduce the temperature. Okay. So when you keep reducing the temperature, you will see that the force of attraction between this liquid will start increasing and slowly they will start getting converted into a solid. Okay, so that point when your vapor pressure of the liquid becomes equal to the vapor pressure of the solid, okay, the point where both become equal, that point will be called as freezing point. Okay, clear, no? So that was about the freezing point. Then now for us important is what? When you have the solvent and to this solvent when you are adding the solute, okay, then what happens to the freezing point? That is our point of discussion here because we are talking for the solution, no? Solvent, we know as you decrease the temperature, the vapor pressure decreases. But when you are adding the solute, that time what happens to the vapor pressure? Okay, that's our point of discussion. So you have seen with graphically, you are able to understand that you have the vapor pressure on this side and temperature on the other side. So this is for the solvent. As the temperature decreases, you see for the solvent, the vapor pressure also decreases. Okay. Similarly, when I'm talking about the solution also same thing happens. Solution as the temperature decreases, you see that the vapor pressure also decreases. Okay. And then on the other side, okay, we make use of the solid also because we are talking when they are becoming equal. No, so I have to take the solid graph as well. Okay, so on this side we have taken this solid frozen solvent which is in the solid state, the solvent itself which is in the solid state, and here the solvent itself which is in the liquid state. Okay, so at this point the vapor pressure of both will become equal. Yes, here they become equal and that point is the freezing point. Okay, so that is the freezing point of the solvent. So I told you if you are talking about the water, it will be 0 degree Celsius. Okay, but when you see for the solution, okay, where you have your solvent plus you have taken certain amount of solute. Okay, now solvent might have got freezed, but when you add the solute, no, slowly you will see that they start getting converted into a liquid. Okay, they don't freeze at 0 degree Celsius. When you have added the solute, they are still here. You can see I am marking here continuously. You can see here, okay, this point. So they are still in the liquid state at this point. Okay, so what you have to do is if you want to freeze them, okay, if you want to convert them into a solid, then you have to decrease the temperature. Okay, you can see here we have to decrease this much amount of temperature. This is the decrease which we should do. Then finally they will come and meet at this point and get converted into a solid. Okay, so that point will be the freezing point of the solution. Okay, this point will be freezing point of the solution. So the freezing point of the solvent is taken as TF naught because it is for the pure one, and the freezing point of the solution is taken as TF. So this extra decrease what you have done, that's the depression in the freezing point. So in the case of when you are taking a solution, you have taken the solvent, and to this solvent when you added the solute, okay, this solute will decrease the vapor pressure. Now, but the vapor pressure has to decrease drastically and it should become equal to the solid. No. So what you have to do? Still decrease the temperature. So that difference is your depression in freezing point. Okay. So this I can write as delta TF can be written as TF naught because higher temperature is for the solvent minus TF. That is the temperature, okay, the freezing point of the solution, which is lower. Okay, so this difference will be depression in the freezing point. So it totally depends. Okay, we write directly proportional to molarity. Molality. Okay, molality for the number of moles means the more the number of moles you are adding, more it will take to freeze. Okay, more time it will take means more decrease in the temperature you have to do to allow them to freeze in the form of a solid. Yes, I believe it's clear. And then I gave you example, lot of example in your daily life. You are a science student, so you are expected to observe the things and find out the reason for, okay, why they are happening like that. So here, if you are talking about the water if you normally take and then keep inside the freezer, okay, maintain your freezer temperature at 0 degree. You will see water solidifies at 0 degree Celsius. But if you are taking water, you have mixed this sugar, you have mixed milk and so many things you have added, okay, like the way you want your candy to be or you want your kulfi or the ice cream to be. So you might have added so many things, okay. So when you add so many things and again if you keep at 0 degrees Celsius, they don't freeze, okay. So they will still remain in the liquid state. So if you want them to freeze, you have to reduce the temperature. Usually we change our freezer temperature to a lower temperature. Okay. So that decrease what you are doing, okay, the lower temperature what you are keeping. So that will be the depression in the freezing point. Okay. Yes, correct. Okay. So yeah. And then all these example now I have put together. Okay. The snow, on the snow when the during the winter season when you have the snow, what they do is they add the salt so that this salt particles will come in between the water. Okay, water molecules, they have hydrogen bonding no between them. So that's why at 0 degrees Celsius they get converted to ice. Okay, solidifies. So you have to break that bond. So that breaking of the bond will be done by adding the salt. Okay, and then I told you about antifreeze also. One more thing is fishes also you might have seen. Okay, fishes, if you want to preserve the fish, they don't only put ice. Have you observed this? Along with this ice, they put certain amount of salt also. Salt plus ice both will be put together, okay, for freezing them, because salt and ice together, they will decrease the temperature. Okay, you can check at home. This you can do if you have thermometer. One side you take ice, measure the temperature. The other side you take salt plus ice. Okay, their temperature will be lower than compared to normal ice. Okay, so this helps you to reduce the temperature. Yes, salt and ice together. So these are freezing mixtures which I used. Okay. Yeah, burning the hand, all that example I told you. Ice and water if you take. Correct. Yes. Okay, so done. The concept is clear, no, for everyone. I believe you don't have any doubt. Now moving on with the derivation. How will you derive it? Okay, derivation is simple. Yes, similarly how we derive for the elevation in boiling point, same way we are going to derive it. The change in the, okay, the freezing point which has happened, that's because of the number of moles you have added. Okay, so we write delta TF is directly proportional to molality. And then you remove that proportionality sign by putting the Kf, okay, which is the constant. So Kf is the constant here. M is the molality. Kf, I said there are different names for it. It is freezing point depression constant or molal depression constant or cryoscopic. Okay, these are the different names for it. So till here we have finished. Now we will substitute for molality. Okay, you know what is molality? Number of moles of the solute. Number of moles of the solute by mass of solvent in kg. Mass of solvent in kg. Okay, so similar way the substitution goes like yesterday. Okay, number of moles is nothing but mass by molar mass, and mass of solvent in kg you have to convert into grams, I told you yesterday. So that for that reason we divided it by 1000. So W1 divided by 1000 is done. Then you directly substitute over here. Okay, rearrange them and substitute here. So you'll get delta TF is equal to KF into 1000 into W2 divided by M2 into W1. So you can see the formula is similar. Only part is this will be different. Okay, delta TF, this will be different. That's it. Rest everything is same. So you don't have to think that, okay, I need to by heart this formula, I need to by heart that formula. It's nothing. Your concept, if you know the, okay, what you are exactly doing, then automatically you tend to remember the formulas. Okay. So this will be your final thing. Then you can find out what is the unit for this KF. KF unit will be similar to what we did yesterday. You can find out KF. KF is equal to delta TF divided by M. What was yesterday's unit for the elevation in the boiling point? You can tell here, okay? Meanwhile, I do on the screen. You can type your answer. Yeah, delta TF is nothing but temperature. So temperature is measured in Kelvin. Divided by, we have molality. Molality is mole per kg, no? Mole per kg it is. Per kg. So this kg goes up. This kg goes next to the Kelvin. So you will get KF value. I'm asking KF value, okay? Yes. So it will be Kelvin kg per mole. Yes. So you can make a note of this now. Quickly write down. Good. Yes, so we got the formula now. Now this everything I have just concluded, okay? That is elevation in boiling point and depression in freezing point. I have just put it together. So when you saw elevation in boiling point, when you took a solvent, you added the solute to this. Okay, we had a solvent. When we added the solute to this, what you saw is this particular solution, okay, if you want them to boil, you have to heat them at higher temperature. That extra heating, what you have done, heating at higher temperature is the elevation in boiling point. Okay, that change what you observed, delta TB, what you observed. Okay, that was elevation in boiling point. So in one sentence, I have put everything. Your whole concept is given in one sentence now. When you take the solute, add to the solvent, that particular solution has to boil, and that will boil at higher temperature. Okay, that is elevation in boiling point. Similarly, when you take the solute and add to the solvent to prepare the solution, okay, and if you want that solution to freeze, then freezing of that solution should be done at lower temperature. You have to decrease the temperature. There we increased our temperature. Here we have to decrease the temperature. That decrease what you did. And when you measure the change, okay, delta TF, that was depression in the freezing point. Okay, so in one shot, you can see everything is given in one sentence. So that you don't have to struggle and read the whole thing. So it's given here. If you want, you can make a note quickly. Yeah, okay. Next, I have listed the formulas together, elevation in boiling point and the rest of the formula. So delta TB, you know, it is equal to TB minus TB naught. So this TB is the boiling point of your solution, which is higher. And this side I have boiling point of the solvent. Okay, pure solvent is always not. And the remaining formula is here, Kb into 1000 into W2 divided by M2 into W1. Okay, next to the other side, depression in freezing point. So what is the difference you are finding here? First, you are having TF naught minus TF, okay, which is the freezing point. This is freezing point of the solvent, which is higher. So that comes first. And the other side, you have freezing point of solution. Okay, so only this is the difference, okay. In the formula for elevation in boiling point and depression in freezing point, this is the difference. So don't get confused and don't interchange. So be very careful. But the next one is similar. Okay, so you don't have to worry much that you have to remember two formulas. Actually, both are the same one. Okay, if mass and molar mass is given, no, this is the one. Only you have to change this. Instead of B, okay, where we have delta TB and KB, here you are having delta TF and KF. That's it. Rest everything you can see, it remains the same. Okay, so this is the formula which you need to keep in mind. It's like almost one only for elevation and depression. Okay, this is important to understand the difference. Yeah, now I'll directly go for problems. And here also, when you're working out the problem, for water, remember, they won't be giving you the freezing point. Okay, freezing point for water is 0 degree Celsius. This I've told you. For there also elevation in boiling point, I told you 0 degree Celsius. That means how much is the temperature? 273 or 273.15 Kelvin to be very precise. This you should be remembering. Yes, good. Okay. Now we will go for the problem. This was yesterday's. Okay, I will just discuss the answer. What is the answer you have got? This is yesterday's problem. Okay, elevation in boiling point. Quickly tell me what is the answer you have got for this. Everyone, you might have worked it out now. It's a board paper question which was asked in 2014 and 2019. So twice this question was asked. All the questions which I have put here, no, all these are board paper questions only. Okay, very good. Yes. How much is it? If you want, I'll just quickly write down what are the terms which is given. On dissolving 2.34 gram of solute, that means W2 is this. Check out, okay, whether your answer is correct. W2 is 2.34 gram and dissolved in which one? 40 gram of benzene. That means W1 is 40 gram. Benzene is the solvent. So W1, no, 40 gram. Boiling point of the solution was higher than that of the benzene by this much. Solution became higher. So I told you when there is a point something or 1 point something or 2 point something, okay, this the temperature if you are finding in Kelvin, that is the elevation in the boiling point. Even same goes with the freezing point also. If you find some point something Kelvin is given, no, that's the diffraction in freezing point, okay. So it won't be much higher for you because hardly 1 to 3 degree difference they are giving. It's for dilute solution. So much difference you don't find. Yeah, so this is the delta TB value is this much. 0.81 Kelvin. And then next what else is given? Kb is given to you. That is 2.53 Kelvin kg per mole. Yeah, when you substitute everything, your final answer is, yes, everyone, most of you have, yeah, correct answer it is 182.72 gram per mole because it is molar mass. So yes, correct. Very good. This is the answer. I'm not working out. You can directly substitute. It's a direct problem. You don't have to do anything here. Yes, very good. I'll go for the next. Okay. Check out whether your answer is correct. If anyone is there who has not got this answer, then see what has gone wrong. Now we'll start with the freezing. Copy down this question. Yeah, we'll work out this problem. Let's see what is given to us. Now here, the problem is 45 gram of ethylene glycol. Formula is also given. C2H4O2. Okay, these are suffix. C2H4O2 is mixed with the 600 gram. Let it be in grams only. Okay, 600 gram of water. Calculate, first question, the freezing point depression. Okay, that means delta TF you need to calculate, and then they are asking you the freezing point of the solution, that means TF. Okay, these are the two things which we need to calculate how much it is. And Kf of water is given 1.86 Kelvin kg per mole. Okay, all this will be given to you. Kf value I had told you it will be given. Okay, now what is this 45 gram? 45 gram is this solute, correct, no? So we can write down what is given. W2, yeah, W2 is 45 gram and I have told you let it be in grams itself. Okay, it should be in gram because already we have converted that molality into grams. So your W2 is 45 gram and then the weight of the solvent, this water, 600 gram. Okay, that is weight of your solvent, W1 is 600. Okay, what else? Molar mass of ethylene glycol you can calculate, no? Molar mass of C2H4O2. Yeah, 2 into 12 because 2 carbon. 2 into 12 plus 4 into hydrogen, that's 1. And then oxygen is 16. So 2 into 16. Yeah, see how much you are getting? So with this you will get the molar mass. Okay, M2, 60, yes, very good. 60 gram per mole, correct? Yes. Most of you are getting 60 gram per mole. 60 gram per mole over this one. Okay, by seeing the molecular formula itself, you can calculate this molar mass. Now, yeah, TF naught is not given to you, but they are telling you water is a solvent. So you can find out TF naught. Okay, so TF naught will be 273.15 Kelvin. Good. Okay, so that is also correct. TF naught of water 0 degree Celsius. So 0 degree Celsius is converted into Kelvin. Keep it in Kelvin itself because we are writing the unit in Kelvin kg per mole. So your temperature should be in Kelvin. What is to find out? Delta TF and TF. Okay. So to find delta TF I can find using the formula, that molar mass formula. Okay. So we can use that to find delta TF. And if I want to find TF, this is our formula, no? Is equal to TF naught minus TF. So using this, you will find your depression in the freezing point. So we will get delta TF. TF naught anyways we know. Then we can find TF. Okay, that is the depression. That is the freezing point of the solution. This you can find later. So first we will go with delta TF. Use the formula. Direct substitution again. Every terms are here only. Okay, so we will go for the next one. You can do simultaneously. Delta TF is equal to KF into 1000 into W2 divided by M2 into W1. Substitute now. Yes, very good. That is correct answer. 2.32, okay? 2.325. Two 2.325 it is, Kelvin. Yeah, correct. This is the answer. 2.325. Yeah, now we got delta TF. You can find no TF now using this formula. Delta TF is equal to TF naught minus TF. TF naught is your pure solvent. So that is 273.15 minus TF. This you know. It is 2.325. Subtract both. So TF is equal to 273.15 minus 325. This will be your final answer after subtraction. Yeah, how much is that? 270 point something. 270 I will write, okay? Many are getting 270. That point is differing because you might have taken different value. This I will keep vacant. Depending on whatever you have got, you write. Okay? But this starting 3 digits are correct, no? So that let it be and then Kelvin. Yes? Got know how to do. This was the answer for your first part, okay? This one, I'll just write the number. This was the answer for your first part. And this was the second part answer, TF. This I left vacant because different answers are there. So you write according to that. So this is the second one. I'll read out this question. So given is 1 gram of non-electrolyte solute when dissolved in 50 gram of benzene lowered the freezing point of the benzene by 0.40 Kelvin. Find the molar mass of the solute. Kf of the benzene is also given to you. Now I will ask someone, they have to tell me what is given here. Yeah, I've just interchanged this. Okay, and then you can substitute whatever values are given to you. So M2. Okay, yes, very good. These many have got this answer. Yeah, 256 gram per mole. Yeah, correct. Okay, only locating this is important. As he said it correctly, it's delta TF. Okay, so remember to find out which is delta TF and which is TF and which is TF naught. So if two higher temperatures are given to you, that one will be TF, one will be TF naught in that. But if it is water case, you should remember. For the not ones, okay, the pure ones, you should be able to remember. Yeah, now we'll go for next quickly. Third one. A solution containing 18 gram of non-volatile solute is dissolved in 200 gram of water, freezes at this temperature. You need to calculate the molar mass of the solute. Kf of the water is given. Yeah, what is W1? Tell me, what is W1? Which one is W1 here?
18 gram.
A solution containing 18 gram of a solute. How do you denote the solute?
W2.
W2 is, so W2 is this, okay? W2 is 18 gram. Next one. Always I've told you, no, lower one is solute. Next, dissolved in 200 gram. What is that?
One is from W1. W1.
That is W1, 200 gram. Yes. Next. What is this temperature? What is this temperature? Is this delta? Is this delta? What did I tell you? Delta should be the least one, no? Now see, read this question properly. A solution containing 18 gram of solute is dissolved in 200 gram of water. That time it will freeze at this temperature. What does that mean? The solution will freeze, correct? No? And how do you denote the solution?
TF.
TF, correct. So TF is given, correct. So TF is 272.07 Kelvin. You are supposed to calculate molar mass. Molar mass is symbol. Molar mass of the solute?
M2.
M2. Yeah, M2. Correct. M2. Now, what else is not given to you which you can write by yourself? Water is a solvent. So,
water.
Water. What is what? Freezing point.
0. Freezing point of what?
Yeah. So, that is what? TF not. Correct, no? How much? You tell in Kelvin.
0.
0 degree. But it should be in Kelvin. So, 273.315. Yeah, you can take 15 or it is left to you 273. Okay, yeah, good. So these are the things. So now here, if you want to calculate the molar mass, your formula is this, no? Delta TF is equal to 1000 into KF into W2 divided by M2 into W1. So now here delta TF is not there. That has to be found out. Okay. So this problem will happen in 2 steps. Yes, Sumuk. Good. Yeah, now you can work out, students. Work out by yourself. Find delta TF first. Then substitute in this and find out the molar mass. Okay, so it has 2 steps. You may get different answer because if you are taking 273.15, it will give you one answer. If you are taking only 273, that will give you one answer. but both will be considered correct because, as I said, we can assume approximately, okay, 273 also.